Good morning, all of you. This is Dr. Shaik Maheboob, Associate Professor in CSC Department of Marri Laxman Reddy Institute of Technology and Management. In the previous sessions, we discussed about the basics of software engineering. Then we discussed about the various types of SDLC models. Then after that, we discuss about the requirements and how to analyze requirement engineering process. Today, we are going to see the next part. Once we collect the requirement analysis, after that one, the next stage is the modeling, that is system modeling. So today we are going to see the system modeling. So what is the meaning of system modeling? Means it is the process of creating the abstract representation of your software, we can say, which is going to tell you about the outside boundaries, you can say, how we are going to communicate with the application software, everything. So this part is important in the designing process. So it will help to the developers, stakeholders and clients to visualize how a system will work. So before going for the coding, we are going to perform this system modeling. So here we are going to do the various types of modeling. Means we are going to present the various types of the designs, diagrams, etc. So let's start. So here systems are typically modeled from four primary perspective to ensure the comprehensive design. So that is, the first perspective are like this: external perspective. So in this one, the system context means how it is going to be interact with the external part or external components. We'll see that part in the example about context model. And second perspective is the interaction perspective. In this one, how the user is going to communicate with the system, we are going to see. So with the help of some diagrams, we'll see that one. Then third one is the structural perspective. So in the structural perspective, it is going to display the organization of the system and structure of its data. So we'll see some diagram in this one, like class diagram, object diagram, etc. Then fourth one is the behavior perspective. So in this one, it is going to illustrate the dynamic behavior of the system, and how we are going to see the flowing of the data with the help of some state diagrams, how the data flows from one state to the another state, what is required, etc. So through the state machine model, we are going to see that part. Let's see then one by one. So why system modeling is important? Means what? So it is going to clarify the system requirements, improves the communication among stakeholders. So mostly this system modeling is very important part for the stakeholders. That's why it improves communication among stakeholders, identifying the issues. Any issues are there in designing, so we can detect it, we can find it. If any issues happen, like communication not taking place or interaction not taking place correctly, we have to observe that part. So identify the design issues early, and reduces the development cost, because once the design is completed, it will goes to the next team, that is for the coding team, that is implementation and coding team will be there. So that's why here, so before, if we do it properly by using the proper modeling, then we can reduce the development cost and the risk. So it also provides the documentation for maintenance. So with the help of this SRS, after requirements, we have prepared the SRS document. Same way here also, for each and every designing, we are going to provide documents for the maintenance. So let's see the different types of system modeling. So we are having basically four main categories of the system modeling, that is context model, interaction model, structural model and behavior model. So one by one we'll see about their examples and the real time scenarios. So first one is the context models. So this model is used for showing the system boundaries. So how it is going to communicate with the outside environment, how the system is going to communicate with your outside components. So here it is going to identify the external system and the actors interacting with the system, as I said, which is used for communicating the outside components, so often represented using the context diagram. So context model, or you can say, or context diagram is used in this context modeling. So for example, in a banking system which is going to interact with the customers, so we are having an ATM system, so through which the users or customers going to the ATM machine, and how they are going to be communicate, means how they are going to use it, etc. So let's see the diagram, then we can understand. So this is one example about your ATM system. For this is the context model of an ATM system. So in this model, if you see, this ATM machine is connected to the various types of the components, like system security, account database, which is used for managing the accounts, like opening the account for customer balances, etc., that can be there in the account database. Then uses database, like what type of transactions done, withdrawal of money, deposit of money, etc. Then maintenance system, if any type of the problems arises that comes through the network, or any hardware changes due to the failure of network, etc. So for that purpose, maintenance system is there. Then we are having the branch counter system, if any types of the issues are there, like suppose sometimes it may happen, you may not get the money, but you will get the messages that amount is debited, etc. So to manage that one, we are having the branch counter system is there, any issues related to the transactions. Then we are having the branch accounting system, in which is used for managing the various accounts for the customers or the users. Then we are having the security system to provide the high level security, we can say, with the by using some encryption or decryption technique. It is going to hide the user details, like pin number is there, okay, account number, etc., from unauthorized access. Okay, so this is a simple example about the context model. So here this ATM machine, it is going to and you can say connected with the various types of the outside components. So that is all about your context model. Now we'll see the next type of the model, that is interaction model. So interaction means what? To communicate, we can say communication between the two persons. So here also in this model, the interaction model is used to communicate between the user and the system. In this we are going to show by using some diagrams how the system is going to communicate with the users or the customers. So let's see in this one, some common diagrams are there, like use case diagram and the sequence diagram, mostly used to show the interaction between the user and the system. So here we'll see some real life scenario, how we are going to communicate with the system. So first one we'll see, that is the use case diagram. So in this use case diagram, it is going to describe the system functionality from the user perspective. So if you observe here, here is an example about this use case diagram. So in this one we are having the actors, like customer is there, ATM technician, and the bank server is there. These are called as the actors. Then we are having some use cases. So inside whatever the activities they are interacting with the system, these are called as the use cases. So we are having the following use cases, like check balances is there, deposit funds, withdraw cash, transfer funds, maintenance, repair. So here the customer is going to communicate with the bank server. Okay, so in this we are going to show the how the communication is taking between the customer and the bank. So whenever the customer is entering, means in this in system, ATM system, they can check the balances, deposit funds, withdraw cash, etc. Okay, so use case, usually you can say it is an interaction between the user and system. So These are called as the use cases. This is the ATM system. Okay, so inside we are going to use the ellipse symbol for the writing of these use cases, and for these actors we are using this type of the symbols, right? Now we'll see the second type of the model, interaction model. One example about the sequence diagram. So sequence diagram shows the messages, means how the user is going to communicate with the system, with the, you can say, the bank or the ATM system. So here if you see, the flowing of the data or the flowing of the messages are taking place between the user and the system. So how it is going to be taking place, the sequence of messages are taking place, so we can show with the help of some sequence diagram. So here some of the steps are there, like suppose any user went or any customer went to the ATM system, how they are going to interact with the system, we can see. So if they went to first, user is going to communicate with the ATM machine, means after entering they will, the user is inserting the card, then after that it is requesting, that ATM machine is requesting a pin. Then once the user enters the pin, after entering the pin, again the ATM sends that pin for the verification with the bank, whether the user enter the correct pin or not. Once the bank verified and validate, then it is sent back to the processing to the user. Then after that one, it is going to display the options like checking the balance, withdraw amount, etc. So these type, so user can select any option, either check balance or withdraw or deposit the money, etc., by entering the amount. All the things are happening in the format of the messages. So these messages, sequence of messages will be taking place, or you can say flow of data or flow of messages are taking place between the objects in some time sequence. So that's why it is called as the sequence diagram. Okay, now we'll see the third type of the model, that is the structural model. So in the structural model, we are going to represent the static way or static structure of the system. So we may use the some class diagrams, what it contains, how many classes are there. We may use the object diagram. So we will see one by one here. So first let us see about the class diagram. So here class diagram represents the different types of the classes, attributes, methods, and the relationships. So in this our example, we are having one example about the library management system. So in the library management system, we'll see how the classes are arranged, what are the relationship between different classes, and what are the various attributes are there. We'll see here. So here simple example about the library management system. So here in the library management system, we are having the various types of the classes which are connected, like users are there, book is the class, then librarian, library database. And here again the user again having the subclasses, like here it is consist of some staff, department, and student class, etc. And here it is also connected with the account class. So in this one library management system, it is going to show the static nature of your overall system. You can see static structure of the library management system. So if you see, if you observe carefully in the library management system, we are having this user type, username, password, login, register, logout. These are the options, or you can say list of the attributes are available for the library management system. So if you go to the user is also having the some username or ID, verify, check account, get book info. These are all the, you can say, list of the actions performed by the user. So verify, check account, get book info, these are the list of the actions, and this name and ID are the attributes. So next is here also we are having this number of the attributes and one method is there, Like same way here also we are having the following attributes. Book contains some title, author, ISBN, publication, etc. So we can use the various types of the operations, or you can say the methods, like show due date and reservation status, feedback, etc. Likewise for librarian also we are having the list of attributes, like librarian name is their ID, password, and the search string. And uh, they are having some operations or the methods like verify librarian and search. These are the operations performed. Then here last one is the library database, which contains the various list of the books, right? So it is the various types of operation we are going to apply for this library database class. So that is all about your class diagram. So it is going to represent the various types of the classes with their attributes, methods, or operations, and how they are related to each other. Now we'll see the second diagram in this structural models, that is object diagram. So usually object diagram show the real-time instance of a class diagram. So object diagrams illustrate some concrete real-world example with filled-in data values to visualize the runtime behavior and validate the class design. So for example, here we can say once we got the class diagram, based on that we can have the object diagrams. So here one example is there for the book management in the library system. Simple example based, because previously I shown the library management system. So here what are the object diagrams for that library management system? So here we'll see we are having the object diagram. Here the user are there, right? And here create book is there. So these are the states, you can say. Entry is there, get book info, add book info, and it is stored in some databases. So here also any update or modified is there, we are going to do that one in this state. Then here borrowing is there in database. So whoever the user is there who are going to get the book from the library management system, so they can do it, be borrowed or update the database in this one. And if after usage of the books and they want to go for the return, so that's why here in library they can return, right, exit or update the database. Likewise here any renewal is there, months 1 week completed, 2 week completed, they want to renew for the same type of the book, they can do it, right? So that's why it can be renewed, or after that or exit or update the database. Then so this process will be carried back for the return, right, if it is going for the exit. So this type of the diagram represents the real time instance of your class diagram. So previously if you see here object diagram, the users are there, they are going for the communicate with the library management system for the issue of the books, right? They may interact with the librarian, or they may browse the library database, etc. Okay, so that is all about the structural model, which shows some structural, or we can say static structure of the system. Now last type of the model is the behavioral model. So in behavioral model, which shows the dynamic behavior of the system, means how the events, how the actions are performing with the system, and what are the various types of the activities are taking place. Like simple example we can say for the online shopping like Amazon or Flipkart or any type of your online shopping, what are the possibilities are there? Usually the user is going to create the account, then after creating the account he or she will search for the items, then adding to the cart, then after that one payment gateway is there, then once it is completed they can track the order, etc. Okay, so that type of the activities will be there for the processing. So here also same example is there. So in this behavioral model we are also having the some diagrams are there. First one is the activity diagram, which is going to show the workflow of the system, how the, like I said the example about order processing, so how the sequence of activities taking place once the customer or the user orders any type of the items, right? So here one example is there for online order processing. So whatever the order are there, it is going to be requested, so it may go to this state and receive order. So that order, if it is accepted or rejected, first one is if it accepted, it will go for the filling the order form. Then after that they are going to send the invoice. Then after that shipping of the order is there. So after sending the invoice, then accept the payment. So you can see any type of the before the payment, after adding to the card, then accept the payment. Then after that one, once the order is completed, it will come successfully close that order. In other scenario, if the order is not accepted, then it will goes to the rejection stage. Automatically it goes to the closing of the order. Sometimes it may happen after placing the order, if the items not available, then it may rejected, or you can say that order is cancelled. Okay, so this type of the online order processing, the example about the activity diagram. Now we'll see the next diagram, that is state machine diagram. So in the state machine diagram, it will show the different states of a object. So here the same example which we discuss here for the online order processing, we are having the state machine diagram. So in this one, we are having the various types of the states are there, like if it is rejected, unprocessed order, or pending order, accepted order, or fulfill order. So if you see the diagram carefully in this state machine diagram, we are going to see the various types of the you can say states of an objects at and process is accepted order. So here if you see, once the order is received, whether it is it will move to the unprocessed stage. So if it is accepted or rejected, if it is rejected means automatically it moves to the rejected order. Once it is accepted means it will move to the accepted order. So if it is accepted, then it is going to check the items, like unavailable will be there. Okay, some items may be available, some may not be available. So if that possibility is also there even after accepting the order, so based on that it is going to process that one pending order. You can say all items are available means no problem, then it will fulfill that order. This also here, some items are available, then we are going to process and fulfill the order. Finally, if all the items are available, then it is goes for the next process, that is for the delivery of the order, etc. So in this state machine diagram, which shows the different states of the object. So this is the part of your uh, state machine diagram. So that will show the behavioral model. Okay, so now we'll see the these are so there. We can use it for the system modeling. Usually we are going to use some ER diagrams in this one, that is data modeling. So in this one, entity relationship diagram, here we are going to show the various types of the entities, how they are connected to each other with their attributes. Okay, so here simple example is there for the student database, that is we are having the entities like student entity and the course entity, and how they are connected. So they are connected with the study. So this is the, we can say, relationship, that is a student studies the course. So each and every student having the some type of the attributes, that is id, name, and age. Student name, age, student id, etc. And these student and course are called as the entities. And here these also consist of what, course id and the course name, we call it as the attribute. So this is the part of the you can say system modeling. Sometimes we may use this type of the models for the data modeling, so which is used for the data structure, showing the relationships, etc. Now that is all about your system modeling. Now we'll see the advantages of the system modeling. So if we do this system modeling, we can we will get the following type of the advantage. We can say, right, better requirement understanding. So in the second phase, that is we discuss about the requirement analysis. So we can understand easily if you go with this system modeling. Better requirement understanding will be there. Improves the system quality, means before going for the implementation and coding or testing part, it is going to improve your quality of the system. Then easy maintenance will be there. Then better documentation, and if any types of the errors are there, that time, or any issues related to the design, then we can reusable design can be done. So these are the various types of the advantages of system modeling. There are some limitation also there, like it will take more time, as we discussed, so many diagrams are there. So that's why based on the designing of the diagrams, that's why that time, so large diagrams will take more time, so time consuming and required some skilled designers. So to draw the diagram, like we discussed various types of the diagrams. So for that purpose also skilled designers are needed. Then may become the outdated. So that's all about your system modeling advantages and limitations. So for this today's session, we'll close here only. Next class, we'll see the system design for the next session. Thank you. These are the references I have took for the this preparing this topic or content. Okay. Thank you.